All
In
right. Hello.
2015, Ethereum launched smart contracts and transformed blockchain forever. Since then, thousands of decentralized apps have successfully launched. But as the ecosystem grew, Ethereum became more congested, creating the need for specialized blockchains. But expanding to new chains is still challenging. That's why we created Moonbeam, the easiest on-ramp to Polkadot. Now, developers can simply deploy existing Solidity smart contracts to Moonbeam and gain access to Polkadot's growing market. Moonbeam's radically simple approach lets you keep the same tools, programming languages, and accounts you already use, meaning you can expand your business and go multi-chain effortlessly and quickly with little to no changes, and unlock an interconnected future. Join the multi-chain movement today, powered by Moonbeam.
All right. Hello, everybody. This is Tracy, the OneBlock community manager. Welcome everyone to join our workshop today about how to implement XCM on Moonbeam. So this presentation will go through some general concepts of XCM, and it will provide a good understanding of how Moonbeam uses XCM to leverage Polkadot interoperability architectures. So both for use cases unique to Polkadot, but also to connect Polkadot to other blockchain ecosystems. The workshop will be around an hour, including the presentation and the QA session. So let's welcome our guest, the Developer Relations Manager Moonbeam, Mr. Alberto Viera, to start the presentation.
Thank you, Tracy. Thank you for the introduction, and thanks for OneBlock Plus for the invitation. This presentation will go in through different sort of like steps. We'll first talk about Polkadot, then we'll move to Moonbeam. We'll talk about, interoperability, XCM. So, there's a lot of things to discuss. So I guess the best way is just to get started, right? So I am going to share my entire screen. By the way, at the end of the presentation, I'll be sharing the slides. So in case you want to review them later on and so on. So, feel free to, leave some questions and for Tracy to ask, and we can get to them at the end. So yeah, as Tracy introduced, my name is Alberto. I work at Developer Relations at Moonbeam. And today we're going to talk a little bit about Polkadot, a little bit about Moonbeam, a little bit about XCM. We're not going to go into code or anything. It's just going to be high level with some technical terminologies and things, okay? But yeah, let's start first with, Polkadot in 5 minutes. This is not going to be like a full summary of Polkadot. It's just to set the tone so that, you understand a little bit about Polkadot and more importantly, its architecture, right? Like why is Polkadot different than any other blockchain out there? And so the idea of Polkadot is specialization and connectivity, right? There is no one blockchain to rule them all. There are many best blockchains out there. And so Polkadot by itself, it's called a layer 0 or a relay chain. And the main purpose is to act as a hub, right? In which it can connect multiple specialized blockchains and it can secure them as well. And so it is not a blockchain to build applications on top. It's just a blockchain that its main purpose is those two things: provide security to these specialized blockchains that can connect to it and basically connect them just because of its architecture. These specialized blockchains are called parachains. And the idea is that each parachain will provide a specific functionality to an ecosystem, right? So this creates a very interesting dynamic because parachains by themselves don't really provide a lot of value, but it's sort of like the entire ecosystem. It will provide a really, really big value, right? Because you will have parachains that are specialized in smart contracts, others are specialized in privacy, others in storage. And when I say specialized, is that they're they're optimized, right? They're built from the ground up, thinking about these features. It's not that you have to adapt and build privacy solutions on top of smart contract chains. You're building the blockchain from the ground up, thinking about privacy, thinking about storage, or thinking about smart contracts. And that really benefits when you're building optimized blockchains for specific purposes. And the other important thing, if you think about how this is laid out, right, that you have all these blockchains connected to the same hub or blockchain, is that you can allow this different participants of the ecosystem to communicate with each other. And this is natively, right? This is not a patched solution on top of multiple blockchains. This is because of its architecture. It allows all these participants to talk with each other in a language that is generally referred to as XCM. And so we're gonna sort of like dive a little bit deeper into XCM later on, but let's just say that this is Polkadot for you guys, right? So with Polkadot now out of the way, let's talk about what Moonbeam is. And so Moonbeam is one of these parachains, and its focus is to provide an Ethereum compatible smart contract platform for Polkadot and beyond, right? And so as any EVM compatible blockchain or Ethereum compatible blockchain, the base layer for that is to have an EVM. An EVM is this virtual machine that it's able to, grab smart contracts, grab transactions, apply the transactions to the smart contracts, and calculate a new state of the blockchain that we're actually talking about. But Moonbeam provides a lot more than just, the baseline EVM implementation. First of all, it is built with a framework called Substrate. And basically, this allows you to very easily connect to Polkadot for native interoperability, as we discussed before. But also, what's really cool about Substrate is that it allows you to make a custom blockchain, right? It provides sort of like this Legos or these palettes, which allow you to provide really cool features that are just really easy to do because Substrate is built with sort of like customizability natively, right? And so it is really easy to sort of modify the blockchain to, for example, provide, extra functionalities, as we'll see a little bit later on in the presentation. Another layer that it's built on top of the EVM is Web3 RPC support, and this provides basically seamless Ethereum JSON RPC integration. What this means is that on Moonbeam, you can actually use MetaMask, you can use Hardhat, you can use Ethers.js, and all the tools that developers that build on Ethereum are used to use, basically, right? So right now, for example, Foundry, it's another tool that it's gaining a lot of popularity. And because we provide this Web3 RPC support, you can use it from day zero on Moonbeam. You don't need to wait until the team does this integration or special, adapts Moonbeam in a way so that you can use these tools. This actually then allows us to create an environment where, all the development tools that people are used to using and all the integrations that developers are used to have are present on Moonbeam, right? So you have things like, Gnosis Safe, you have Chainlink, you have Etherscan, which is called Moonscan, and you can use all the development tools that you're used to using, right? I mean, you can write contracts in Viper, in Solidity, you can use, Waffle, Truffle, Hardhat, Foundry, Web3 Python. So it doesn't really matter. As long as you can use it on Ethereum, it will work with Moonbeam out of the box. And you have also indexers like the Graph, right? So it is this like Ethereum environment, but in a separate blockchain that it's called Moonbeam. And last but not least, this is what separates Moonbeam from other parachains in the Polkadot ecosystem that offer similar things, is our unified account style. And at a high level, what this means is that on other parachains that have EVM compatibility, you have sort of what is called the Substrate accounts, which is an account that you use for things that are outside of the EVM, like staking, governance, XCM. And then you have your EVM account, like, for example, the one in MetaMask, that is the one that you will use to interact with smart contracts inside of the EVM. In Moonbeam, we have modified the underlying account system so that you can use your EVM-styled account or Ethereum-style account for everything. And so that is why, if you've ever gone to the Moonbeam app, you can actually do staking using MetaMask and Ledger using the Ethereum application, or you can actually vote using your Ethereum wallet and so on. And these are features that are not part of the EVM in Moonbeam, but you can still use these Ethereum-style wallets. And I've mentioned before that Moonbeam offers an EVM with expanded features, right? And why is this? And this is part of what I mentioned, that Moonbeam is built with Substrate. And with Substrate, you can, customize a lot of your blockchain features. And so with that in mind, if you take a step back and you think about what Moonbeam is part Substrate, part Ethereum, right? And so it has an EVM with expanded features. So let's say a person, let's say Bob, he wants to interact with the Ethereum side of Moonbeam, right? So this would be, once again, a smart contract or a dApp build on top of Moonbeam using the EVM. And so this person will actually interact with something called the Ethereum interface. And this is the Web3 RPC that I was mentioning before. But that means that this person can only interact with the things that are inside of the EVM. If the person would love to, let's say, use the features that are part of Substrate, meaning staking, governance, XCM as examples, the person needs to use the Substrate interface. And the problem here is that these features don't really offer way. You cannot actually access these features via a smart contract because it's outside of the EVM. It's not inside of the EVM. And so what Moonbeam provides is a set of precompiled contracts. They're written, they have an interface, for example, in Solidity, which can be called from the Ethereum interface so that you can access these advanced features. And this allows you to build, for example, smart contracts on top of Moonbeam governance, on top of Moonbeam staking, on top of Moonbeam's XCM. So you can have smart contracts that use XCM to communicate with other blockchains in the Polkadot ecosystem. And not only that, there are actually precompiled contracts that allow you to, for example, use advanced features that Moonbeam offers, like the batch precompiling, which you can batch a bunch of transactions into one call for the user to sign, or the call permit precompile, which allows any call and any smart contract to be gasless, which is something that is not possible to do on Ethereum, for example. And so, Moonbeam is not just an EVM. It just provides a better development environment for developers to take advantage of all these advanced features, which is actually pretty cool. So now let's talk about consensus and cross-chain, right? We discussed about Polkadot. Now we discussed about Moonbeam. Let's go now to what it's consensus and what it's cross-chain. So at a very, very high level, that this is not going to get technical, a consensus is a general agreement, right? For example, if we have a family and we want to decide what restaurant we want to go for dinner tonight, we're going to come to a consensus, right? Let's say, 3 out of 5 wants to go to a burger place. That is a consensus. But the thing is that we know each other, right? We're a family. We know each other. It's really easy to trust each other's judgment. But the tricky part in a blockchain is that the consensus needs to be a general agreement in what is the next valid state between people that don't know each other, that they don't trust each other, and it's a decentralized network. That's the whole point about decentralization, right? And so if you think about that, proof of work, proof of stake, all these terminologies is how they achieve this consensus, this decentralized and trustless consensus, okay? And so let's say we have a blockchain in which, the state of that blockchain, meaning the state could be the balances of everyone that are participating in this blockchain. Let's say Alice has 10 tokens and Bob has 0 tokens. And then next to the states, you'll have a list of transactions, which is basically what the consensus needs to sort of the runtime needs to apply to the state to calculate the new state, basically. And this list of transactions, we're saying that Alice sends 5 tokens to Bob. Okay. And so if you think about it, right, if you then calculate the next state is going to be that the next valid state is going to be that Alice had 5 tokens and Bob has 5 tokens. And then there has to be a way, proof of work, proof of stake, that everyone can agree that the next state is Alice has 5 and Bob has 5. Okay. Because I don't trust anyone in the network. They don't need to trust me. But we can come to agreement that is the next valid state. But then let's say that Alice now sends 10 tokens to Bob, right? Interestingly, if there's a malicious person in the network, the person can say, I know Alice, she's my friend. I'm going to actually try to create a block in which the state is now invalid, okay? So actually, sorry, I know Bob. And so now, if you think about it, if the consensus it's decentralized and trustless enough, even though one person says, I'm going to include this transaction in this block to calculate a new invalid state, everyone else can just say through a mechanism, hey, buddy, this is not right. And so the state will be 5 and 5, okay? I am generalizing a lot of things here, but the idea that you need to understand is that consensus is what tells you the next state of the blockchain, if it's valid or not. So now if we apply that knowledge to standard GMP protocols, right? What is a standard GMP protocol? What is GMP? GMP stands for General Message Passing, and it's a way to connect isolated consensus systems. Okay, so let's say you have, Ethereum is one consensus, and then Moonbeam is another consensus, right? And so there's no way they're actually like isolated islands. They don't really they don't even know that the other blockchain exists, right? And so how can you actually, blockchain one, how can they tell blockchain two that they want to do something in blockchain two? And for that, the standard, like the GMP protocols exist for that purposes specifically, right? So the main idea of GMP protocols is that they connect isolated consensus systems, okay? And so message passing relies on these GMP protocols, which are basically intermediate consensus. Okay. So if consensus one or the blockchain one, once you send the message to a blockchain two, this message will be picked up by this, intermediate person or like entity, which is this GMP protocol. And they also have their own consensus mechanism to agree whether this message is valid on the other blockchain that they're going to execute it on. Right. So, I mean, this GMP protocol consensus can be as easy as a multisig, or, as complicated as multi-party computation multisig, or you have like Axelar, which has a proof of stake network on top of the consensus that they use to pass messages to other networks. And so there are different mechanisms to decide this middle part here. And now basically, if the GMP protocol then approves this message being passed from blockchain one to blockchain two, they will execute the message on blockchain two, and blockchains to consensus will actually check if that state transition was valid, right? So think about what this means, right? You have basically three consensus mechanisms acting independently, and there's a trust basically between consensus one and consensus two, because you have this middle protocol which is with its own consensus, right? And so this is like the weakest chain of the link, right? And so on Polkadot, this is a little bit different if you think about it, because Polkadot architecture, right? Parachains are already trusting Polkadot for security, right? They're actually asking Polkadot to be its consensus. So Parachain A and Parachain B, they don't have a consensus to say, hey, this next state is valid or not. That it's given by Polkadot. And so the beauty of it is now, Parachain A can send a message, in this case it's an XCM message, to Parachain B, and basically they don't need to rely on a middle an intermediate consensus, because they're already relying on that consensus already. Okay. And so the beauty of it is that they're all part of the same sort of like trustless and decentralized environment, in which they just basically send an XCM message and hope it gets executed. And then basically they are trusting the same basically consensus mechanism. So there's like little less trust in this case. And so basically XCM execution on Parachain B will result in a state change that is verified by the same consensus that it's Parachain A is using, right? And this is what Polkadot calls share security, which is this nifty feature because it provides interoperability in a native way, basically. So, all right, we've talked about Polkadot, Moonbeam. Now a little bit about interoperability in general terms and why Polkadot has an advantage in terms of interoperability. Let's talk a little bit about what XCM is. And so XCM, from a this is a very practical and simplified perspective, right? This is not technical. This is basically a way that you can understand XCM at a high level, and then if you want to sort of like deep dive into it, you can continue along. But XCM, it's a combination, it's a message with instructions, basically, right? I always give this analogy in which XCM is like a letter that you normally have like a standard to write that letter. You can say, hello, the introduction part, then you would ask the person how they're doing. Then you tell a little bit story about yourself, and then, a goodbye message or a saying goodbye message, right? XCM, it's a little bit like that. It's a message with instructions, with a format, okay? And so each instruction by itself, it doesn't do anything. It's very, it doesn't do anything productive, right? But a combination of instructions that are executed in the target chain will result in a concrete action. Another analogy that I like to give is that if you tell me to stand up the chair, I will stand up, but nothing will happen, right? But if you tell me, Alberto, stand up, go right, walk 10 steps and flick the switch, the light will actually turn on, right? So a combination of instructions resulted on the light turning on. But if I just do one instruction by itself, it's not going to do anything. And so in this example on the right-hand side, you have, parachain A, let's say Moonbeam, is going to send a message to chain B or parachain B with a set of instructions. Part of the instructions can be executed on parachain A, and part of the instructions can be executed on parachain B. It just doesn't really matter as long as the action that you're trying to do gets, results in whatever action you want it to do. And so, for example, if we're going to do a token transfer on Moonbeam between Moonbeam and another parachain, you actually need to include an instruction called transfer reserve asset on that is going to be executed on Moonbeam, and then you build the XCM message so that the instructions that are received by the parachain B and executed are this following 4 instructions. The purpose of this presentation is not to go through the instructions themselves, but just letting you know that each instruction, when it gets executed, there's something happening, and then this combinations will result in something happening. Later on, we're going to do a similar example in which we're going to go through each instruction so that you understand it a little bit better. If you want to remotely execute something, let's say you want to call the staking module of another parachain, you can actually do it with this following instructions, right? You don't need to do anything on parachain A, that is optional. And then on parachain B, you need to at least include these instructions, right? So these instructions are a way that you can execute something on parachain B, but the signer or the person that signed the transaction actually was on parachain A. And this is really cool because it means that you can actually control accounts on other parachains without having to switch your wallet, move to that parachain, connect to it, blah, blah, blah. You can actually do it from the parachain A or the origin blockchain. So one important, let's say, concept that we need to understand is basically sovereign account. And the sovereign account, it's an account that each parachain has in the other blockchain, basically. So Moonbeam, which is this one with color, has an account on, let's say, A star parachain, or it has an account on Akala or an Equilibrium, right? So, and that account is owned by the entire parachain, so by governance, basically. The only way that a user can access a sovereign account of another chain is through governance, right? I cannot just call my wallet and execute something on behalf of Moonbeam because that would be very dangerous. So this is important to understand because when we go through the examples, you're going to need to understand what the sovereign account is. So let's jump right to it then in the XCM examples, right? So we are, 1 second, sorry. Yep. Cool. So we are going to sort of go through an XCM message that it's actually going to execute something on the remote chain. And so the first thing that we're going to do is remote transfer. So basically what happens with parachain A sends some tokens to parachain B. So this is the first XCM instruction. So transfer reserve asset. If you remember correctly, that was in the list that I showed you before. But basically what happens here is that Alice, or the person that wants to send tokens, let's give a practical example, right? Let's say Alice on Moonbeam, she wants to send Glimmer to the A-Star blockchain, right? And so Alice will actually get deducted a balance of Glimmer, but she is going to transfer it to A-Star's sovereign account on Moonbeam, right? So remember that A-Star has a sovereign account on Moonbeam. And so basically Alice will transfer these tokens to A-Star's sovereign account on Moonbeam. And then an XCM message with the instructions is going to be sent to parachain B, okay? So when parachain B executes this instructions, the first one is going to be reserve asset deposited. And this is going to create like a representation of Glimmer in this parachain, right? So it's going to be called XC Glimmer or whatever, however, A star denominates this cross-chain tokens. And it's going to put it in a state that is called holding register. Let's say it's like a shopping cart where, you don't own it because you have not paid for it, but it's there in the shopping cart waiting to be utilized somewhere, okay? So now glimmers are created and they're going to be put in the shopping cart where, you still don't own it. The next step is it's an instruction called clear origin. This is basically because this instruction, it's executed from Moonbeam's sovereign account. And so now for security reasons, you're going to delete that information. It is not that important, but just, just to be correct, this instruction needs to be executed for security purposes. What's going to happen next is that you are actually using the other parachain, right? So you're actually executing code on that other parachain. And for that, you need to pay. It's similar to Ethereum that when you're doing a transaction on Ethereum, you need to pay for fees. This is the same, but it's in a cross-chain scenario, right? You need to pay for fees on Moonbeam and on A star because you're going to utilize both chains. And so in this case, you're actually saying if I send 100 glimmers and I created 100 XC glimmers or the cross-chain asset of Glimmer, I'm going to actually use part of that Glimmer, which is in the shopping cart, just to pay for that execution, okay? So that's why you're not getting 100 Glimmer on A star. You're probably getting 99 glimmers or something like that, okay? And last but not least, the last instruction is the one that when it gets executed, it's going to grab all the tokens from the shopping cart and it's going to transfer them to Bob, which is the destination address that Alice on Moonbeam decided to send it to, okay? So once again, think about what this means. Like every instruction by itself doesn't do anything because, for example, to deposit the assets, you need to have minted the asset, and that it's another instruction that is doing that. You need to buy execution and so on. And so the combination of instructions resulted in Alice on Moonbeam transferring glimmers to Bob on A star in this example. If you want to do it the other way around, so if you want to move tokens from Bob to Aleph, in this case, you need to use a separate set of instructions that for time, I'm not going to go through them in detail. But in this case, you're using actually withdraw assets, which will take these tokens and put them in the holding register on A star. And then basically, this withdraw asset, it depends, right? It could be either from Bob or it could be in the sovereign account. In this case, the message when it gets executed on Moonbeam, the parachain B sovereign account, in this case, A star, will actually get the tokens that it was holding before. That it was when we Alice transferred the tokens to A star sovereign account. In this case, A star sovereign account is going to get the tokens deducted. It's going to buy execution with these tokens, and then it's going to deposit the assets to Alice in this case. So once again, if you transfer 100, you're going to get 99 on A star. And if you transfer 99 back, you're going to get, 98 on Moonbeam just because you're paying fees with the assets that you're transferring, okay? The other example is remote execution, and this is the one that I meant to mention earlier, but it's very similar. At the end, there's a lot of terminologies that are gonna go, are gonna be actually, you're gonna hear quite a lot when you're actually dealing with XCM things. When you do remote execution, basically what you're trying to do is that you're gonna in the remote origin, let's say on A star, you're actually gonna deduct some tokens from the sovereign account and you're gonna put them in the holding register. So in this case, let's say we're gonna, do something on A star in which we're gonna pay with it using, Glimmer or whatever. And so basically, our account on A star is gonna get deducted these tokens on A star and gonna put them in the shopping cart. Because we need to buy execution. Once again, we need to pay for the transaction fees that we're doing in this cross-chain call using these tokens that are in the shopping cart. And then we're gonna execute whatever bytes you want on the remote parachain. So in this case, these bytes can be go to this module in A star and call it using these parameters right here. So on the case of Moonbeam, for example, you can actually do remote staking, right? So let's say you're on Polkadot and you want to stake glimmers on Moonbeam. You can actually use this XCM messages to say, I want to grab my account on Moonbeam, and then I want to execute these bytes so that I'm going to actually stake, 100 glimmers to this collator. So this is really cool because this is going to start, we're going to start seeing sort of these cross-chain scenarios in which you don't really need to move to the destination parachain with your wallet to do an action, right? You're going to be able to interact with Moonbeam's EVM contracts and applications from the parachain that originally your wallet is connected to. So let's talk a little bit about Moonbeam and XCM. So this is basically everything that I mentioned before is very generic to all the parachains in Polkadot. But let's now discuss a little bit to what Moonbeam is doing uniquely with XCM and its application and beyond XCM, right? So Moonbeam, Polkadot, but also Moonbeam and other ecosystems like Cosmos, Avalanche, Ethereum, Binance Smart Chain, and so on. But the first thing is that Moonbeam introduced something called the XC20s. And this is really cool because this is basically an ERC20 token. You might have heard ERC20 tokens before, but it allows ERC20 tokens to be shipped around to other parachains, right? So imagine I create Albert token on Moonbeam. If a parachain wants to have Albert token, they can just register Albert token in their own blockchain, and I can ship my token, Albert token, to that parachain that wants it, right? And that's really cool because Albert token, it's an ERC20, right? It's a token that can be added to dexes like Uniswap or lending protocols or things like that in the EVM. But it has this extra feature, this extra substrate feature that you can actually ship it or send it via XCM. And that is also true for assets coming from other parachains to Moonbeam, right? Or even the Polkadot. So for example, Polkadot's token DOT lives as an ERC20 on Moonbeam, right? So that's why you can actually, put it in lending and borrowing protocols like Moonwheel. You can deposit it to, dexes like BeamSwap and StellaSwap. And that is because all the assets on the Polkadot ecosystem that are registered on Moonbeam, they exist as ERC20s. So it's really cool because it goes both ways, right? I mean, any ERC20 on Moonbeam can be sent via XCM to any, Polkadot parachain, but it is also true on the other way around. Any asset on parachains or Polkadot will live on Moonbeam like an ERC20. And this means that you can use anything on the Ethereum API like Hardhat, Truffle, Web3 JavaScript, Ethers, Foundry, etc. to interact with these like cross-chain assets. And then the other really cool thing that we're actually still working on is this idea of connected contracts, right? So the idea of connected contracts is that there's no blockchain right now that is fully isolated, right? I mean, blockchains by themselves are isolated, but now we have this GMP protocols that allows us to be connected to other blockchains. And so a deployment of contracts on Ethereum can be aware that there's deployments of contracts on Moonbeam, Cosmos, and any other sort of like ecosystem that exists. And so this is really cool because now if you create a smart contract, a set of smart contracts on Moonbeam, right? Every chain that Moonbeam is connected to can access that deployment. And we're talking about, Moonbeam is connected to all the major blockchains out there because it has integrations with Wormhole, with Layer 0, with Axelar, with Hyperlane, just to name a few, right? And so Moonbeam is very uniquely positioned because it can be like a gateway to enter, to go in and out of the Polkadot ecosystem, right? We've seen examples of protocols moving DOT from Polkadot to Osmosis and Cosmos using Moonbeam, right? So you will use XCM to move DOT from Polkadot relay chain to Moonbeam, and then you will use, for example, Axelar to move those dots from Moonbeam to Cosmos into Osmosis. And that's really cool because that really opens up the possibilities of things you can do, right? And this example we call port of call is, like I said, it's a point of transmission in and out of Polkadot. One of the things that it was recently announced is called Moonbeam Routed Liquidity, or MRL, in which the idea is that you can actually Moonbeam can act as a hub of assets for the Polkadot ecosystem, right? So let's say Hydra DX, which is a kind of like an AMM, yep. automated market maker. They want liquidity from Ethereum, from Avalanche, from BSC, but they don't have an EVM, right? So for example, bridges like Wormhole, Layer 0, Axelar cannot connect to Hydra DX directly, but they are connected to Moonbeam. And so you can grab all this liquidity from Ethereum, from Avalanche, from Polygon, from BSC, and route it through Moonbeam so that it enters Moonbeam via these protocols, and then it gets shipped to Hydra DX, for example, via XCM, which is really cool because it sort of like unlocks this liquidity for Polkadot parachains. But the truth is, like, the other way around is also possible, right? So let's say, for example, Interlay token, they want to access a liquidity pool on Ethereum, right? They can bridge it to Moonbeam via XCM, and then all these GMP protocols that are connected to Moonbeam can be used to ship that token to Ethereum and put it in a liquidity pool on Ethereum. And so it has been really interesting to see the team's reaction on MRL, because it's going to provide a lot of usability. But the whole point of MRL is to provide one-click experiences, right? So that you build this port of call in a way so that a user that wants to send liquidity from Ethereum to Hydra DX, there's only one click, and that's it. Basically, the liquidity gets routed directly to the account that the user set on Hydra DX. And so the idea of connected contracts is that you can provide this cross-chain experiences that are very seamless in UX. They're very good in user experience. They're very frictionless in terms of usability, but they're actually kind of complex for developers to implement. And so, a lot of tools are being built to reduce that barrier of entry, so that this is something that developers can actually use in their toolkit to, access, for example, identity protocols like Kilt on Polkadot, right? And so Moonbeam is very uniquely positioned because its unmatched Ethereum compatibility allows to be connected with all these GMP protocols, but it's also part of Polkadot. So you have these specialized chains being built that need things from outside of the Polkadot ecosystem, or things outside of the Polkadot ecosystem can actually tap into them as well. So I would say that those are the two main things that Moonbeam is working on at an XCM level. We're also exploring ideas with other parachain teams of how, for example, people on Moonbeam or deployments on Moonbeam can tap into Kilt's decentralized identity services, or Interlay's decentralized Bitcoin, right? So these things are natively off Polkadot, but we're actually starting to explore this XCM integrations here in 2023. So yeah, I would say that was right on time. So hopefully the XCM bit was not too technical. It's a lot, to be honest, to digest. I've been dealing with XCM for over a year and a half now, and it's still pretty difficult. So yeah, thanks a lot for listening in. There's this QR code of the slides. You also have the URL there. If you want to follow Moonbeam on Twitter, it's at Moonbeam Network. We have our Telegram official channel, our Discord. You can check our website as well. There you'll have more information about all the different social channels. And on the right hand side, if you want to follow me on Twitter, is the Alberto V19. And also you can reach me in Telegram directly. I try to be as helpful and as responsive as I can. So yeah, thanks again for the invitation. And Tracy, I don't know if you have any questions or anything in particular.
Thank you, Mr. Alberto. So dear audience, if you have any questions, please let us know. And it's going to be our QA session. So actually, we gathered several questions from the community in advance. So the first question is going to be, can Moonbeam's address be directly used on other parachains in Polkadot?
Yeah, that is a great question. So let me go back to it on a slide that I have. There you go. This one is a good one for this. So, not really, okay, and but not really, but kind of, and it's a tough question to answer, right? Because basically, Moonbeam uses Ethereum style accounts, right? This is called ECDSA cryptography and so on, so that Moonbeam has a very unique account system compared to other blockchains. Other parachains, right? Other parachains use SR255.9 cryptography, and they use basically what we call substrate style accounts. And so you cannot just grab your private key on Moonbeam and then try to connect that to any other parachain in the ecosystem. That's not going to be possible because the derivation is not correct. Okay, but using XCM, and this is something that we're actually there was just a standard release on Polkadot with this like next upgrade that it's going to happen soon, that it will make it possible to have a standard so that Alberto on Moonbeam, so my private key on Moonbeam, can control an address on any other parachain, right? So even though it's not going to be the same address that you have on Moonbeam, for example, let's say I have an account on Akala, right? So let's say I don't have the same address on Moonbeam and Akala, I will be able to control an account on that parachain via XCM on Moonbeam. Okay, that seems really complex, but think about what happens if all the complexity is abstracted from you, in a nice interface, right? So I always give this example of like, imagine I'm a user on Polkadot, but I want to tap into Moonbeam. I want to, send my dots into a liquidity pool on Moonbeam in a DEX, right? So using that method of controlling accounts remotely, I would never need to use MetaMask, right? Imagine I use whatever wallet I prefer on Polkadot, and then I can just from if we have a nice application built on top of both chains, you can just hey, how many tokens do you want to send to your Moonbeam account? And yeah, I want to send 10 dots. Okay, perfect. And then where do you want to put it on? Stella Swap, Beam Swap, and you can just select, for example, one of these two, and then just click send, and then an XCM message will be built for you, right? That's a tricky part. So that it will result on transferring the token, the dots, to your account that you controlled on Moonbeam via XCM, and then using that account to buy, to use remote EVM calls to go and deposit these dots on whatever protocol you like. So that's why I said it's a tricky answer, because you cannot really use it, but you actually can using XCM kind of. Hopefully that answers it.
Okay, thank you, Mr. Alberto. Yeah, the next question is going to be similar, like relating with the address. So the Moonbeam address is a H160 address, which allows the users on Moonbeam to use both Substrate and Ethereum functionalities with the same H160 address. Does Moonbeam's unified account currently support Subsocial parachain?
Yeah, so I mean, it's a similar question, like you said, Tracy. Like, Moonbeam account system, it's completely separate from Subsocial, right? So you could, in theory, you could from Moonbeam interact with Subsocials. Let's say there's a social application built on top of Subsocial. You can actually have an account on Subsocial that you control from Moonbeam, right? So you can use, for example, your Ledger. You have your Ledger device, it uses H160 accounts, like you said, and Moonbeam uses H160 accounts. But because on Moonbeam you can send XCM messages using H160 accounts, means that you can actually control an account on Subsocial to just use your favorite, social application built on top of Subsocial, right? So yeah, I would say yes, but the way that you can integrate Moonbeam with Subsocial, it's a little bit different because you need to use XCM for that.
Okay, thank you. So next question is going to be for developers and project teams. What are the advantages and convenience of using XCM on Moonbeam compared to other cross-chain solutions?
Yeah, that's a great question, actually. I think the main benefit is what I discussed before about the precompiles, right? So let me jump into that really quickly. Okay, precompiles. So the main benefit, this is not the right slide, this one. So the main benefit of using, for example, XCM on Moonbeam, let's say compare it to other, first let's compare it to other parachains, right? Compared to other parachains, the main benefit is that Moonbeam has a very, its Ethereum compatibility is unmatched right now, right? We make design decisions to be as Ethereum compatible as possible, basically. And so the cool thing about using XCM on Moonbeam compared to other parachains is that you can write smart contracts on Solidity, right? That can use this advanced XCM features to connect to other blockchains. One of these really cool examples that I used to give is Lido, right? The Lido implementation on Moonbeam and Moonriver, which is being like shut down. But when they implemented this feature, it was really cool because they were actually using Moonbeam's EVM to actually do remote staking on Polkadot. So you could stake dots, on Moonbeam. You just connect your wallet to Moonbeam. You would just open the application, sign with your Ledger or Trezor or MetaMask or whatever, and then you would actually be staking dots, which is, I don't know if you've ever tried to stake dots, is somewhat complicated, right? So this is one of the connected contracts examples that I like to give because it provided a much better user experience, and you were using sort of this like XCM on Moonbeam, through these precompiles. Compared to other cross-chain solutions, let's say, you're comparing XCM to any other GMP protocol, Axelar, Layer 0, Wormhole, Hyperlane, multi-chain, whatever you prefer. I would say that the main benefit of XCM is basically it's that it's native of Polkadot, right? If you remember what I was talking about here, right? So in this example, you need to rely on an intermediate consensus that it's not the same as consensus 1 or consensus 2. Right, it's a separate consensus that it might have its own hiccups. Right, we have seen all the hacks that have happened in bridges. I mean, recently, lately, whatever, in the past 3 years, and that is because there's a flaw or something breaks in this intermediate consensus. It is never on blockchain 1 or blockchain 2. It's normally in this middle step right here. But on Polkadot, right, these parachains already have consensus from Polkadot. And so the main benefit of using XCM compared to this is that it's native, right? You're already trusting this consensus, so there's no risk of having like 3 consensus mechanisms needing to trust each other more or less to pass a message, right? So I would say that it's like the main advantage.
Okay, cool. Next question is going to be, has Moonbeam considered performance and scalability issues when implementing XCM? Are there any limitations or bottlenecks?
That's also a great question. So, right now, Moonbeam is running in what we call a limited performance stage or state, because we rely on Polkadot. In a lot of things, we rely on Polkadot for performance, right? Because Polkadot is giving us the security. And so, when XCM really opens the floodgate of transactions on Moonbeam, that could create a bottleneck, right? But there's in Polkadot's and Moonbeam's roadmap, there are things that are going to come quite soon that will actually improve performance by a lot, right? So we have asynchronous backing. This will allow probably to expand the capability of Moonbeam by 4x or even more, like 8x. And so ideally, there will be improvements done because remember that, like I said before, compare other blockchains, right? You only have in blockchains like Ethereum, you only have Ethereum and that's it. On Moonbeam, you have multiple components, which is Moonbeam and Polkadot, right? And there's separate blockchains working together. And so there are many sort of like things on the roadmap for Polkadot that will improve sort of like the throughput. And this will be important because if you want to use XCM very sort of like naturally or like natively, that's going to create a lot of XCM payloads, right? So yeah. And right now, for example, we've never hit sort of like a limit, a rate limit or something like that in XCM. It's still far from that, but if there's an uptick, we might hit it. So yeah.
Okay. Next question is about, is the implementation of XCM affected by off-chain activities such as oracles, dApps, etc. On the Moonbeam network? Are there any security risks or potential attacks?
Well, if you think about what XCM means, right, and going back to this image right here, it's a set of instructions that get executed, right? So these set of instructions are general enough that they're very isolated from like oracles and things like that. But that really depends on how, for example, the oracles are implemented, right? So, for example, if you're using XCM to do cross-chain lending or whatever, and there is an issue on the destination chain with the oracles, your XCM experience is going to be affected, but not by XCM itself. It's just naturally what happens in this sort of scenarios, right? So because XCM, it's sort of like a message that just gets executed with a an action resulting of the execution of that message, I don't see like a problem with like off-chain activities affecting that, right? I mean, as long as the message can be executed, right? So if Moonbeam sends a message, right, it's asynchronous, it's not atomical, meaning that Moonbeam's going to send the message and it's going to hope that the parachain B executes that message, right? So long as that flow is not affected and the state transitions are done correctly, I don't see a way, particularly that off-chain activities can disrupt XCM. But I mean, it's really hard on the spot here to think about all the possibilities and edge cases, right? So I don't want to put myself on the spot saying that there's like no risk. There's always risks, right, associated to these sort of things. So yeah, I would say that at the top of my head, it's really hard to think about some scenarios.
Okay, thank you. The next question is still relating with the risk. So yeah, how does Moonbeam ensure the decentralized and censorship-resistant nature of XCM implementations? Are there any mechanisms to prevent potential attacks or malicious behavior?
Yeah, that's also a great question. And I did a presentation in Sub-Zero. Yeah, Sub-Zero last year. You can actually Google it. So maybe I can put it here in the chat, where we discussed some like monitoring tool that we created to sort of like monitor XCM a little bit, right? So I mean, think about what I was mentioning before, right? I mean that Moonbeam and any other parachain already relies on Polkadot for consensus. So in theory, the only affected factor that could happen on XCM is when an XCM message gets sent to another parachain, that the other parachain executes it the way that parachain A was expecting it, right? So let's say, for example, you send a message to transfer 100 tokens, but then parachain B suddenly, instead of creating 100 tokens, creates 1,000 tokens. There's an issue then with sort of parachains B logic on executing XCM. So that could be sort of like problems. But if you think about how token transfers work, remember that in token transfers, in parachain A, parachain B has an account where these tokens are sent, right? So if I send 100 tokens, what's going to happen is that there's an account, parachain B has an account of parachain A that is going to hold these 100 tokens. So even if they mint 1 million tokens here, the scope of the attack, it's only 100 tokens on parachain A, which is what it was valid originally, right? So the state transitions are still valid on parachain A. What's happening is on parachain. Well, the problem is happening on parachain B. So in order to sort of like monitor that, on Moonbeam, we have sort of what we call XCM monitors, which allows us to, I'm looking for the presentation, which allows us to sort of like check if this like integrations, specifically for token transfers, which is like the easy ones to do, if these integrations are actually are keeping this sort of like equality between blockchains, right? And so we've had incidents in which we've needed to notify other parachains about what we call token imbalances, meaning that, for example, if parachains B sovereign account on Moonbeam has 100 tokens, there needs to be 100 tokens on parachain B, but we've noticed 100.1, for example, right? And so these imbalances need to be corrected, and so we do keep monitoring we do keep monitors for these imbalances. So I've shared, by the way, hopefully you can see it on YouTube, but I've shared a link to a presentation that I did in Sub-Zero where I explain a little bit more of all these like monitors that helps us debug XCM and make sure that we can control risks.
Okay. Next question. For ordinary users, is it convenient and friendly to use XCM cross-chain interaction on Moonbeam? Are there any like learning costs or technical barriers?
So I would say if developers do their job correctly, XCM should not be hard to use, right? If you go to, for example, the Moonbeam dApp, you can bridge DOT from Polkadot to Moonbeam in a very sort of like straightforward way. That doesn't mean that it's it's not the easiest thing to do, but you need to understand like what are you doing. For example, that you need to go to Polkadot, select Polkadot, put the amount of tokens, review the transaction, and sign it. But the idea is that developers need to ensure that the experiences that they create are good for end users, right? So I would say that getting a grip on XCM is not easy for developers, but it is not impossible, right? And then the things you can do and to build on top of XCM are really cool, and they can be really intuitive for end users. And so I would say here the burden lies more on developers than on end users, because if developers create really good UX on top of XCM, they might not even understand that they're using XCM, like the Lido example that I was mentioning before, right? And that for me is like the dream come true, right? When you're actually using a technology without realizing that you're using the technology. That would be the pinnacle of like XCM. So yeah.
Good. Yeah, we have only the last questions. We have very good like time management. We only have 5 minutes left.
Definitely.
So yes, yeah, perfect. So yeah, for the last question is going to be for the adoption and the promotions of XCM. Is there have any like plans for that? And are there any partners or projects already using XCM for cross-chain interactions?
Yeah, that's also a great question. So we are pushing really hard on Moonbeam to ensure that there's this like remote accounts standards that I was mentioning before, right? So this image here in which an account on Moonbeam can control an account on any other chains. We're pushing really hard for other teams to start exploring ideas and possibilities of what this means, right? Because if you think about it, that means that any user on any chain on Polkadot can use another parachain, right? And that will definitely unlock a world of possibilities. So imagine, for example, a user on Moonbeam being able to access, Bifrost's liquidity staking solutions, but from Moonbeam, which is the goal here. And so I would say that we're pushing really hard for this to become a standard, because that's going to help sort of drive adoption. Because the idea is that developers can, if they build really complex XCM applications, users are not going to use it, right? They're going to shy away because they don't really understand what they're doing, etc., etc. I would say nowadays the most complex, but from an application perspective, but they have a pretty good UX. XCM use case is this like one that I was mentioning before, in which you have like DOT moving from Polkadot to Osmosis via multiple, XCM plus Axelar and so on. And this other one from Lido, which is like remote staking using XCM, which is, for me, it's like a great example, because if you, I mean, right now they're shutting it down, but I think there will be other solutions coming up that if you ever did this, the UX was just perfect. Like you didn't see any complications. It's like, how many dots you want to stake? 5. Stake, and that's it. You would just sign with your wallet, and that's it. And so I think that teams need to think about this, like when they're building cross-chain applications. And I gave at least a couple of examples. But there's more being explored, like Moonbeam routed liquidity, right? And I know that, for example, Moonbeam has an SDK called the Moonbeam SDK, which is going to provide a lot of tools for developers to sort of build, XCM related things an easier way. And there are teams like Apollon, which are building like toolkits for developers as well to do this cross-chain integrations with multiple parachains within the Polkadot ecosystem. So I think adoption is still, like we need to work more on adoption, but I think it's coming because, people are understanding XCM a little bit more, and then they're understanding also how to build good applications on top of XCM, which is the goal, the end goal. So.
Thank you. Yeah, last 50 seconds for me. Yeah. Thank you, Mr. Alberto, and thank you, everyone. If you have any other questions, please follow our guest Twitter and DM him. So let's call it a day and see you around. Bye.
Yeah. Thank you, Tracy. Have a nice one, and thanks for the invitation. Bye, everyone.